Assalamualaikum warahmatullahi wabarakatuh. Today we're gonna explain about technique of differentiation. Our group consists of 4 members, which is Muhammad AIMAN bin FIRDAUS, Muhammad ARIEFF FIKRI bin NORHISHAM, AZIZIEY bin KADAR, dan Muhammad FAIQ HAFIY bin ZULKIFLE.
Hello, my name is Muhammad HAFIY, and today I will be explaining on the definition of differentiation. So what is differentiation? Differentiation is a process in math where we find the instantaneous rate of change in function based on one of its variables. So allow me to give you a real-life example where differentiation is implemented. Imagine you are driving a car and your car is moving forward. The distance you travel is changing every second. In mathematics, we can represent that distance as a function of time. Now, if we want to know how fast the car is going at any moment, that is where differentiation comes in. By finding a derivative of the distance function, we get the speed of the car. So in other words, differentiation helps us find the rate of change of distance over time. So, the speedometer, right, in front of your steering wheel is actually showing you the result of a real-time differentiation. All right, let's move forward to the techniques of differentiations. There are a total of 6 techniques of differentiations that we are currently learning. And first we have power rule, then constant rule, and then product rule, next quotient rule, chain rule, and finally implicit differentiation.
So first problem we have y equals to sine x power of 2 times power of 4x over x power of 2 plus 1 power of 2. So it's a little complicated, but we make it easier with the logarithmic differentiation. So step 1, take the natural log of the both sides, which let us break the function into smaller parts. Step 2, differentiate each part using the chain and product rules. And then step 3, multiply by the original function again to get our final derivative. So after we simplify, we get this as our answer, which is dy dx equals to sine x power of 2 tan power of 4x over x power of 2 plus 1 power of 2, and then open bracket 2x cot x power of 2 plus 4 secant x cosecant x minus 4x over x power of 2 plus 1, then we close bracket. Okay, now for the second problem, y equals to ex power of 2 cos ex over square root sine negative 1 for x power of negative 1, sorry. So here we use the quotient rule. Step 1, find the derivative of the top using the product and chain rule. Step 2, find the derivative of the bottom using the inverse trigonometric rules. And step 3, plug everything into the quotient rule formula. So after simplifying, we get our final answer. So even though this function looks good at first, breaking them into steps, making it much more easier.
Hi, my name is AIMAN. In this part, I will be explaining the question 3. The question given is find dy dx by the implicit differentiation for cosine of x square plus 2y plus x times e to the power of y square equals 1. Step 1, we differentiate the first term, which is cosine of x square plus 2y. For this, we will refer to the trigonometric derivative rule. According to this table, the derivative of cos fx is f prime times sin fx. Here our fx equals to x squared plus 2y. So our f prime is 2x plus 2 dy dx. After we apply this, we got negative 2x plus 2y 2 dy dx times sin of x squared plus 2y. Now we can extend this so it becomes negative 2x sin of x squared plus 2y minus 2 dy dx sin of x squared plus 2y. Step 2, we differentiate the second term, which is x times e to the power of y squared. This is a product of two functions, so we apply the product rule. We let u equals to x and v equals to e to the power of y squared. The u prime equals to 1. For v prime, we use the exponential derivative rule. derivative of e to the power of fx is f prime times e to the power of fx. In this case, our fx is y squared. Now the f prime is equals to 2y dy dx. Now using the product rule, which is uv prime plus vu prime, we got 2xy e to the power of y squared dy dx plus e to the power of y squared. Step 3, we differentiate the third term, which is 1. The derivative of 1 is just 0 because the derivative of a constant is always 0. Step 4, we combine both left and right side and find the dy dx. First, we group the terms that has the dy dx on the left and the others on the right. After that, we can factorize the dy dx term on the left side. Then, we can divide both sides to isolate dy dx. And that's the final expression for the derivative dy dx.
Okay, for the next question, we have use differential to estimate the value of 15.98 minus 15.98 over 4 square into the correct 2 for decimal place. So for the first step, we need to find the x0 and delta x. So the x value is 15.98 and the nearest value of x is 16. So we have to calculate it to get the delta x. So we have x minus x0, which is 15.98 minus 16. And then for the second step, we have we need to break this into two parts and insert x0, which is 16 into each part. So we have divide it. So we get fx equal to x1 over 4. And then we substitute the value 16 into x, which is we get 16 1 over 4. And then we get the value 2. And for the gx, we have x over 4 squared. And then we get x squared over 16. And then we substitute the value 16 into x, we get 16 squared divided by 16. And then we get 16. So for the third step, we have to differentiate each part and insert value of x0, which is 16 into each part. So we have to differentiate fx. We get f prime x equal to 1 over 4 x power negative 3 over 4. So we sub the value 16 into x, we get 1 over 4 times 16 power negative 3 over 4, we get 1 over 32. Then we differentiate gx, we get 1 over 16 x squared, and then we get 2x over 16, and then we get x over 8. So we substitute the value 16 into x, we get 16x over 8, we get 2. And then for the fourth step, we have to insert all the value into the formula, which is f x0 plus delta x fx plus f prime x times delta x. We get f16 plus negative 0.02 2 plus 1 over 32 times negative 0.02. We get 1.999375. And then for the gx, we have the same formula. And then we substitute the value g16 plus negative 0.02. And then 16 plus 2 times with negative 0.02, we get 15.96. And then we have to calculate it. With the previous answer we get, which is 1.99375 minus 15.96, which is we get negative 13.9606.
To wrap up, this assessment required the student to investigate a range of differentiation techniques such as product rule, chain rule, implicit differentiation, and linear approximation. This enabled them to gain a deeper understanding of the methods involved and how to use them correctly in addressing calculus problems. It is recommended that students should practice more questions with various function types and use all of these differentiation methods. This practice will enhance their confidence, knowledge, and skills to use them on both academic and real-world problems. Thank you.